Number 3, the sum from n equal 1 to infinity of the square root of n plus 1 over n squared plus 2. Again, this looks like a p-series. Why does it look like a p-series? Because it's n's raised to powers. I need to find out what the leading terms are. Well, it might be confusing because it's the square root of the whole entire thing, so I know that I could distribute that square root to both numerator and denominator and rewrite this series as the square root of n plus 1 over the square root of n squared plus 2. Now that leading term in the numerator is the square root of n, and the leading term in the denominator is the square root of n squared. Well, the square root of n can be written as n to the 1/2 power, and here the square root and the squared will cancel and you're just left with n. If I reduce n to the 1/2 over n, I get 1 over n to the 1/2. This is the p-series that I'm going to compare it to. So I'm going to compare it to the sum from n equal 1 to infinity of 1 over n to the 1/2. What do I know about this p-series? Well, p is equal to a half. A half is a number that is less than or equal to 1, therefore I know that we are going to diverge. If we diverge, this guy here has to be the smaller series. Since it has to be the smaller series, that makes it a sub n, and the given is going to be your b sub n. Now we have to do the comparison. 0 less than a sub n less than or equal to b sub n. Well, since I'm comparing them and this guy here or this guy here has a square root, instead of writing it as 1 over n to the 1/2, I'm going to write it as 1 over the square root of n. So my a sub n is 1 over the square root of n. Is that actually less than or equal to the square root of n plus 1 over n squared plus 2, our given? Well, I don't know right now, but I can square both sides of this inequality. If I raise both sides to the second power, I have just 1 over n. Is that less than or equal to n plus 1 over n squared plus 2? Not sure. Go ahead and cross multiply. 1 times n squared plus 2 is n squared plus 2. Is that actually less than or equal to n times n plus 1 is n squared plus n? If I cancel out the n squareds from both sides, I'm left with 2 less than or equal to n. So this actually lets me know that 0 is less than a sub n, which is less than b sub n, for, if we read it backwards, n's greater than or equal to 2. What this is saying is that this inequality holds true for n's greater than or equal to 2. It's part of that note that we had before saying as long as this inequality holds true for all n greater than some integer n, then we can use the direct comparison test. So all that this is saying is that for n's greater than or equal to 2, a sub n will be the smaller series, and that statement then allows us to use the direct comparison test. Therefore, now we can say that by the direct comparison test, our series diverges. Example 4 is the sum from n equal 1 to infinity of 3 to the n over 2 to the n minus 1. First, determine, do I look like a geometric series or a p-series? Well, it's a number raised to the nth power. Since it's a number raised to a power, I look like a geometric series. I still do the same thing. I figure out leading term over leading term. The leading term of my numerator is 3 to the n. The leading term of the denominator is 2 to the n. Well, we can rewrite that since they're both raised to the nth power as 3 halves to the n. So I'm going to compare this to the geometric series, the sum from n equal 0 to infinity of 3 halves to the n. Here, the absolute value of r is 3 halves. Well, 3 halves is a number that is greater than or equal to 1, therefore we know that this is going to diverge. If it diverges, it must be the smaller series, which makes this a sub n, and it makes the given b sub n. go to your comparison. 0 less than a sub n less than or equal to b sub n. A sub n is your 3 over 2 to the n, but I'm going to write it again as 3 to the n over 2 to the n because it's going to make the comparison easier. 3 to the n over 2 to the n. Is that actually less than or equal to b sub n, your given, which is your 3 to the n over 2 to the n minus 1? I'm not sure, but I cross multiply. 3 to the n times 2 to the n minus 1. I'm just going to write that as 3 to the n times 2 to the n minus 1. Is that actually less than or equal to, multiply the other side, 3 to the n times 2 to the n? Well, notice I have a 3 to the n that I can divide out from both sides, so it's going to cancel. And all I'm left with is 2 to the n minus 1. Is that less than or equal to 2 to the n? Yes, absolutely. Since that inequality holds true, we can then say that therefore by the direct comparison test, our series diverges.